Hi everyone, myself Satya, Department of Mathematics, SNS College of Technology. So already we saw basic terminologies and few theorems in the last class. Today also we are going to have the same topic graph, but today we are going to have special types of graph. What are the types of graphs we are having? So the first thing is regular graph, a graph in which all the vertices are of same degree. Then that is called regular graph. Okay, you can see few examples listed here. Graphs. The first graph is 2 degree, which is common, right? Next also degree is common. Next, yes, degree is 2, which is common for all the vertices. Next one is 3 and next is also 3. Okay, so which is called 2 regular and 3 regular graph. Regular graph means degree should be same. Complete graph. In a graph, there exists an edge between every pair of vertices. Then such a graph is called complete graph. There should be an edge between every pair of vertices. Okay. So every complete graph is regular. Every complete graph with n vertices is n minus 1 regular graph. The complete graph on n vertices is denoted by kn. K1 means only one vertex. K2 will have 2 vertices. K3 will have 3 vertices. K4 will have 4 vertices. Okay. K is nothing but it's a complete graph. Okay. Bipartite graph. A graph G is said to be bipartite if its vertex set V of J, which is partition into two disjoint non-empty sets V1 and V2, then we are finding the union, then we will get the whole set, such that in which way we need to find the sets. So every edge in E has one vertex in V1, the other vertex in V2. That way we need to form two partitions, V1 and V2. Okay, we'll check it here. C6 is a bipartite graph. So we need to totally will have V1 to V6, 6 vertices. Now we are going to find the partitions. So V1, V1 is, you can take V1 to V2, you can have V1 in one vertex and V2 in the other vertex. And V2 to V3, so V2 in V2 and V3 in V1. Okay, that way we can take. Okay, if we are considering one edge, one vertex in one set, the other vertex in the other set. That way we need to form the partition. Okay. And the next thing is, in the similar way you can consider all the edges. Don't leave any edges, to consider all the edges. For all the edges, if this condition is satisfied, then we can form a partition. That partition, that type of graph is called bipartite graph. So now here V1 is V1, V3, V5. And V2 is V2, V4, V6. Okay. So it's a bipartite graph because we are finding the partition, right? In K3, which is not bipartite, how? Yes. Since because all the vertices are adjacent. If all the vertices are adjacent, it is not possible to find two partitions. Okay. So we cannot find the partitions. Okay. Suppose we are taking V1 and V3 edge. You can consider V1 in one set, V3 in the other set, and go for V1, V2. V1 in one set and V2 in the other set. Okay. V2, V3 edge. So both the vertices are in the same set. That means it is not possible to find the partition. So from this we can say it is it is not a bipartite graph. Okay. And you can see this graph. Here also it is not possible to find the partition. Okay, because many of the vertices are adjacent to the other vertices. If the vertices are adjacent, okay, then it is not possible to find the partition. If the partition is not possible, then we cannot find the bipartite graph. Okay. The next thing is complete bipartite graph. So first it should be a bipartite graph with bipartition is called complete bipartite graph if every vertex in V1 which is adjacent to every vertex in V2. So already we know the concept for bipartite. So additionally we are adding one more concept, which is every vertex in V1 which is adjacent to every vertex in V2. Okay, so clearly every vertex in V2 which is adjacent to every vertex in V1. Okay, a graph with m and n vertices in the partition, which is denoted by KEMN. You can check it here, 2, 3. In the first partition, we are going to take 2 vertices, and in the second partition, we are going to take 3 vertices. Okay. So in the second case, both equally 3, 3. So that way we can find the partition. After that, we need to check whether the vertices are adjacent. Okay. The vertices of V1, capital V1, that is the set, which is adjacent to the vertices of V2. Okay. And the next thing is subgraph. When we say a graph having a subgraph, so V dash which is contained in V and E dash which is contained in E. That way we need to form the subgraph. The graph which is said to be a subgraph, if all the vertices and all the edges of H are in G, the adjacency is preserved in H exactly as in G. That way we need to form the subgraph. Okay. Each graph has its own subgraph. A single vertex is a subgraph. If single edge is a subgraph, if you are deleting the vertex, automatically the edge will be deleted. If you are deleting the edges, automatically the vertex will be deleted. Okay. Thank you. The remaining thing we'll see in the next class.